How do we count sig figs? Let's learn the rules. Rule number 1. This means that they are always going to count. For example, 3.243. How many sig figs does this one have? Let's count. 1, 2, 3, 4. All of these numbers are non-zeros, so we have 4 sig figs. Rule number 2. Now let's do an example. Let's say we have 3.0256 sig figs. Now someone made the mistake that this would only have 4 sig figs because we're not counting the 0. But since these two, 3 and 2, are non-zero numbers, the 0 will count. So we have 1, 2, 3, 4, 5 sig figs. Rule number 3. Now let's do an example. Let's say we have 4.4300. Now this would have 1, 2, 3, 4, 5 sig figs because trailing zeros always count. Rule number 4. An example of this would be 0.0006. Well, let's see. This is a leading 0 because there is no significant number on the left of it that makes it count, makes it be significant. So this is not sig fig, not sig fig, and not sig fig. Therefore, we have 1 sig fig 6. How do we keep track of sig figs when adding or subtracting? Let's keep track of sig figs while using this subtraction example. Now what we have to do here is treat this problem just as any other subtraction problem. So what we would have is 21 minus 13.8. And our answer would be 7.2 grams. When adding or subtracting with sig figs, your answer must be according to the number that has the least precise decimal place. This always will be the decimal closest to the left. In this case, 21 is the number that has the least precise decimal place and has 2 sig figs. Since 21 has 2 sig figs, our answer also must have 2 sig figs. And since our answer is 7.2, we don't need to round it anymore to sig figs because it already has 2 sig figs, 7 and 2. And that's how you keep track with subtraction. So let's use our example. 1.05 times 10 to the negative third power mole divided by 6.135 liters. Well, what we're trying to figure out is how to keep track of our sig figs when we're multiplying and dividing. Well, the way that you do this is your answer must always have the amount of least sig figs that you find in your original problem. For instance, over here, we have 4 sig figs, 1, 2, 3, 4, and we have 3 sig figs and 1.05. And since 3 sig figs is our least amount of sig figs, our answer must have that amount of sig figs. So when you put this into a calculator, your answer is going to be 0.0001714. Now let's count our sig figs. We know from our rules that leading zeros never count unless a whole number is in front of them, in which this case there's not. So we skip these zeros because we know they're not significant, and since we need 3 answers in our sig figs, we are going to go to this place and we're going to have to round 1 and 4. We got rid of 4 and 9 since all we needed was 3 significant numbers, and we have them right here, 171. Now, don't forget to put in your units, which would be moles per liter. And this would be your answer, and that's how you keep track of sig figs when using multiplication and division.
How do we keep track of sig figs when using addition, subtraction, multiplication, and division?
So we have our example here, 15.5 grams minus 23.056 grams plus 104.0 grams over 1.245 mole. So what we're going to need to do here first is keep track of our sig figs when we're doing the top part, which is addition and subtraction. And we know that we need to find the number where the decimal is in the least precise area. In this case, it would be 15.5, and that has 3 sig figs. So whatever answer we get for here must also have 3 sig figs. Now, we're going to need to use a calculator, and we're going to punch in 15.5 minus 23.056 plus 104.0. Our answer is 96.444, and we know that we need 3 sig figs. So what we're going to need to do is we're going to put a stop here, and now we know that we need to round from 4 to 4. This means that we're going to leave our answer at 96.4. So now we have 96.4 grams over 1.245 moles. Now this is a division problem, so we're going to need to go back to our multiplication and division rules. And what we know is that our answer must have the same amount of significant numbers just as the least amount of significant numbers in our original problem. So in this case, it would be 96.4 because that has 3 sig figs. Now, when you put it into a calculator, 96.4 divided by 1.245, our answer would be 77.42971888. So we know for sure that this isn't the amount of sig figs that we want. We want 3. So what we're going to need to do is, once again, we see we have 3 significant numbers. We stop at the third significant number and see that we have to round. So we round 4 with 2. So now we know that our answer is going to be 77.4 grams per mole. have 3 sigfigs, just as we have 3 sigfigs here. And over here we have 3 sigfigs, just as we had in our original problem when we were subtracting and adding the top part.